Hello and welcome to this new video. The training continues, and today I'm going to solve a case from last year Road to Las Vegas series, which is called What is my flight number? Which is actually a very nice case, quite different from the other ones. So I enjoyed it a lot during the actual competition. I will solve it right away. So let's go into the case. Basically, you are provided with a list of flight routes between airports, and you have codes basically. So there are two standards in the aviation industry: the IATA code, which is a 3 letters designation for a certain airport, and also the ICAO code, which is a 4-letter designation. Then you basically need to understand different things. For example, here it is very simple: what is the departure city for each of the following flights. Then you're asked to understand how many kilometers are flown in total, and then assign flight numbers basically to the different lists. You're also provided with this flight routes tab, where you basically have the cities, the distance between them, and also the departure time, which is part of the schedule we will have to solve in the next level. So having said that, I've already imported my usual solver worksheet. So let's start from level 1, which asks what is the departure city for each of the following flights. I think you will leverage some name ranges, so let's call this cities. Let's call those this, and those are the ICAO's code. Okay, and now it's just an XLOOKUP of text before this, before minus, looking in these codes and returning the cities, and that should be it. Yes, it is. Assuming that the airline adopts the following 10 flight schedule, how many kilometers are flown in total? Let's move to the solver worksheet. So we have example 2, that's the list. I'm going to text split the list. Okay, over this delimiter. Potentially, I think the easier thing to do is to text join with this, the XLOOKUP of both of those in cities, the other way around, so the codes I want to return. Yes, so this will be a simple XLOOKUP of this over this one, returning the distance. And also let's call this x, and I want to substitute x with space kilometer, nothing. Okay, no space probably. Okay, and I need to convert this to number, and I'm going to sum and scale it. Didn't even check whether the example was right. Yes, so let's go for level 2, and it's correct. So now you start assigning the flight numbers. You decide to assign the numbers in the order that the schedule is listed, but to make it more interesting, every flight arriving or departing from Canada, Montreal, or Toronto must have a 7 in it. Okay, I remember this this thing tripped me up quite a lot during the competition. Now I have a decently clear idea on how to address this request. So first of all, let's move to example 3. The list is clearly longer. Let's scale the kilometers even if those are not needed. Let's split those because I will need both cities to be considered. Montreal, Toronto are Canadian flights. So Canadian. If or those equals Canadian. It's 1, otherwise it's 0. I don't know if this is working, honestly. Apparently yes. And so let's address this with an array formula because I think it's easier. Of course, this is not helping me at all. Okay, so let previous number, let's say, is this. Next 10, I will do a sequence of 10 starting from previous. Okay. 7 check, if not is error. Find a 7 in next 10. It's 1, otherwise it's 0. This should give me a list of ones. So if this equals 0, is just previous plus 1, otherwise is it should be the index of next 10 matching 1 in 7 check, exit match. That's it. So 0. So 78 should be my answer. No, 107. Okay, there is clearly an error here. I think this should be previous plus 1. Okay, otherwise it's not increasing. Okay, so 107. Let's reference this and let's scale it. I didn't start the timer, but I probably made 1 or 2 minutes introduction. Okay, that's right. Level 4, now you have to abide by NAA rules and must assign the flight numbers according to the following 2 rules. Flight numbers must be assigned in order starting from the earliest departure of the day based on the departure time in the flight routes table. If the airline operates a return flight for a given trip, the number of the return flight must be exactly 1 more than the original flight. For example, if the company operates a flight from London to Las Vegas, this flight is assigned flight number 9. And later in the day, the company operates a Las Vegas to London flight, then this flight must be assigned flight 10, no matter at what time in the parts. Okay. Let's go for it. So this will be example 4. First of all, that's my target list. Let's scale the logic. So first of all, let's XLOOKUP this into my flight schedule, return the departure time, which of course should be formatted as time. Okay. So I need to understand if this is the first flight or the return flight. So the opposite, let's build the opposite, will be the concat of this, and this. Okay. Is the opposite in the list? Let's look up this into this lock. Okay, so if is error this, it means I don't have maybe let's also look up this. Okay, so if is error this, it means it's first one. Otherwise, if this is greater than this, it means it's a return flight, otherwise it's a first flight. So in this case, this is later than the previous one, so that's a return flight. This is the only one, so it's the first flight. This is a return flight. This is the first flight. Okay. So, having said that, let's try to rank this in this ascending order. And then a trick that I remember quite well, so if this equals first, I will keep it, otherwise I will do a next lookup of my opposite flight into the schedule, returning the time, no, returning the rank plus 0.5, and then I will rank again this over this ascending, and at this point I will do an index of this matching this here, exit match CPT YYZ, so as parentheses light. So what I did is basically ranking ignoring the returns, and then if basically that's a return flight, it means it needs to be right after the original flight. So I added 0.5 because the rank actually is based on integer. So that's the idea basically, and that's it. I think let's try to see if this scales. Okay, the data table is taking forever to update. This is clearly an issue that I need to manage during the battles, otherwise I will go crazy over the usage of my solver worksheet. Okay, that works. It's a mess. The system broke down and flights now have mixed IATA and ICAO codes. Furthermore, by safety reasons, the airline will not operate flights longer than 15,000 kilometers. So any flight longer than 15,000 kilometers in schedule must be ignored. Aside from this, the same rules as level 4 apply. Okay. I think I will do a copy of this to not break the logic. Example 5. Okay. Okay, and so let's do an XLOOKUP of this into iChaos returning yatas, and if I don't find it, I will return this. Something is not going as expected. Probably it's because of the array here. I don't know why, but I'm assuming it's not working. Like this. Something wrong is going on. Okay, the table taking forever again. Okay, I will build it again. The text join this. This will now reference to this one. Let me delete this data table because it's clearly too heavy to manage. Canadian, I don't need it. Neither this. Time. So filter, because I need to remove the 15,000 based on this. Standard equal to 15,000. Okay. So potentially that's my big list. So time now goes here. Opposite. Let's build again the opposite flight. That's the XLOOKUP here and here. That was the formula to copy. Okay, flight routes are okay. Return. Okay. 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 And any error here probably. Okay. And I think, let's see, yeah, apparently it's working. Let's update. So it, okay, not really. What? 71 is not working. 72 it is. Seems quite strange. It's probably due to some misbehavior of the data table. I mean, I will simply do like this. Data table crashing again. Oh no. Don't tell me I lost all the work just before completing level 5. That's annoying. Okay. Okay, that will be my answer. Okay, so I think we have all the levels solved. So out of the possible flights between 2 of the 12 listed cities, how many are not in the airline's flight routes? TrueGuard level 1 to 4, excluding example, which city is the most common destination? Enter the city name, not airport code. Which flight schedule in level 5 assigns flight numbers that are multiples of 3 to all flights departing from Riga? Okay. First one. To the possible between 2, how many are not in the airline's flights? Okay, what if I do like this? That's spilling. That's interesting. Transpose, yeah, it does. Got this. This to flight routes. Flight routes. Lock. If I this. It's 1. So 41 minus 12. Okay. TrueGuard level 1 to 4. Which city is the most common destination? So destination will be always this one. So IATA's transpose IATA's. Okay. Sequence of 70. WT. And then some this. I will say 139 CPT. Their city name, Cape Town. Yes. Which flight schedule level 5 assigns flight numbers that are multiple of 3 to all flights departing from Riga? Which flight schedule level 5 assigns flight numbers that are multiple of 3 to all flights departing from Riga? Okay, so if first of all Riga is RIX, if this is not this, then 0, otherwise that's RIX. If mod this 3 equals 0, so wonder why it's 0. What's the question? Flights cannot send flights number that are multiples of 3 to all flights departing from Riga. So I want to capture where a flight departing from Riga, flight numbers that are multiple of 3 to all flights departing from Riga. Okay. So this needs to be 0. If error 0, sum of this. Okay, no. Oh, I hard coded this. No, there's something wrong here. So 77 RIX. $59 divided by 3. Equals 0. It's the opposite. It's the opposite. So 95 apparently. Should be right. Yes, it is. Right, spot on the 30 minutes plus some 1 minute introduction and commentary. It will make it a successful performance, but that's not for sure the first time I did this case, so doesn't count, of course, as a live attempt. I hope you enjoyed this one, and we'll see you in the next video. Bye.